Hey guys, welcome to another video. In this video, we're going to be solving two questions from Unit 5, which is one rational function and the other is an exponential function. So I didn't write the questions because the questions right now should be very obvious. So the first thing we need to do to analyze a rational function is to find the domain of definition. So for number one, when we want to find the domain, now what is the domain of definition? It's basically all of the x's that allow the function to exist. In other words, if we want to find what number makes this function undefined, it is basically 2. Because since x minus 2 is the denominator, that means the denominator should never be equal to 0, which means that x should never be equal to 2. Therefore, the domain is going to be minus infinity, 2, union 2, positive infinity. Okay, notice over here that the brackets are curved. That means that 2 is not included in the domain. And we also put curved brackets whenever we're dealing with infinities as well. And this is it for basically number 1. Now, number 2, we need to find the limits of the domain. And we need to see the existence of any vertical, horizontal asymptotes. So first of all, let's study the limit at infinity. So limit as x is going to negative infinity for f of x. Since we're going at negative infinity, it means we can take highest power over highest power. So it's essentially x to the power of 2 over x. Therefore, I can cross out 1x over here with the power over here, and this is going to leave me with limit as x is going to negative infinity for x, which is going to be negative infinity. Now, since I'm going to the infinity side, I am testing the existence of a horizontal asymptote. But since the answer is negative infinity and it's not a number, it's not a regular number, it's not a constant, that means there's no horizontal asymptote over here. Now, similarly, for at positive infinity, I'm not going to repeat all of the process. It's literally the same exact thing. So it's going to be positive infinity, which means no horizontal asymptote. Now, the extra two limits that we're going to study is going to be at 2 minus and another one at 2 plus. So when we want to study it at 2 minus, in the numerator, it is allowed for us to replace x with 2 because the numerator has no impact whatsoever on the answer. So it's going to be 2 to the power of 2 plus 5, which is going to be 4 plus 5, which is going to be 9. And in the denominator, we are obliged to put x as 2 minus. So we're going to put 2 minus minus 2, as we can see over here. So what is 2 minus? 2 minus is microscopically smaller than 2, which can be represented as 1.9993 dots. It goes on forever. So if you are subtracting 1.99999 minus 2, it is going to be a negative number, but it's also going to be a super small number. Like it's going to be microscopically small, and it's going to be negative as well. So we are going to represent it as 9 over 0 minus. So any number over 0 should be infinity, and the positive number over the negative number is going to be negative. So over here, I have x is going to a number, and the answer is infinity. Therefore, x equals 2 is a vertical asymptote. Now, similarly, also, I'm not going to do it with full details this time. it is going to be 2 plus minus 2. Now in this case, 2 plus is going to be represented as 2.0003 dots, 1. So it's going to be microscopically bigger than 2. And a number microscopically bigger than 2 subtracted by 2 is going to be a number very close to 0 but positive. So it's going to be positive infinity. So this gives me, again, the same exact information as 2 minus, which is x is equal to 2 is a vertical asymptote. Now, hold on 1 second. Okay, so now we are finished with number 2. We basically found the existence of a vertical asymptote, but the non-existence of a horizontal asymptote. So now in number 3, it's basically find f prime of x and construct the table of variation. So f prime of x, first of all, it is going to be u prime v minus uv prime over v squared, because why? This function is u over v. So it is going to be 2x multiplied by x minus 2 minus x squared plus 5 multiplied by 1 over x minus 2 to the power of 2. This is essentially going to give me 2x squared minus 4x. So it's going to be x squared minus 4x minus 5, because 2x squared over here, it's going to be 2x squared minus 4x, and this is going to be minus x squared minus 5. So the simplest form is going to be as such, x minus 2 to the power of 2. Now we need to check for any critical points, and in order for us to check for any critical points, I have to put the function equal to 0. The f prime is equal to 0, of course. So if I'm going to put the f prime is equal to 0, I can cross multiply. So if f prime of x is equal to 0, then x to the power of 2 minus 4x minus 5 should be equal to 0. So using the calculator, we can find mode 5.3 that a is going to be 1, b is going to be negative 4, and c is going to be negative 5 will give us two roots, which are basically 5 and negative 1. So x1 is equal to negative 1, and x2 is equal to positive 5. So now we are ready to construct the table of variation. So now, once we draw our table, hold on, let me make it straight. So x belongs in the first row, f prime belongs in the second row, and f belongs in the third row. So now, the first thing you need to do is that you need to put the domain and the critical points in the first row. So it's going to be minus infinity, positive infinity. We also have a discontinuity at 2. So we're going to draw a wall. Now we can place the critical points. So we have a critical point at negative 1, and we also have a critical point at 5. So we know that f prime becomes 0 at these two critical points. Now we need to find the sign for f prime. Now in order for us to find the sign of f prime, we can literally just find the number between 5 and positive infinity. We can choose, for example, 6. So if you choose 6 in between and you plug it in f prime, so you can plug it in over here, you're going to notice that this is going to admit a positive answer. And then if you choose a number between 2 and 5, let's say 3, if you plug in 3 in this function over here, it's going to give a negative answer. And then if you are going to plug in a number between negative 1 and 2, let's say for example 0, and you plug it in the function again, you're going to get a negative number again. And then if you are going to plug in a number between -1 and -infinity, let's say, for example, -2, if you're going to plug it in the function again, f prime, it's going to give you a positive answer. So again, in this case, you are doing trial and error. I won't waste time to tell you exactly like each trial and error what number it will be. But again, if you choose a number between 5 and plus infinity, let's say 6, and you put it in f prime, it is going to give you a positive answer. So this is why I put positive. And if you do this technique for a number between 2 and 5, a number between -1 and 2, and a number between -infinity and 1, it is going to be according to the signs I just wrote in the table of variation. So this is how you guarantee that your table of variation is correct, by doing trial and error. Now f is going to be very easy. When it's plus, it's going up. When it's minus, it's going to go down. When it's minus, it's going to go down. When it's positive, it's going to go up. So now, once you finished your table of variation, you need to fill in the numbers in. So first things first, you have to fill in the limits. The limit at -infinity was basically -infinity. And the limit at positive infinity, it was positive infinity. And the limit at 2 minus, so it is right over down here, it was -infinity. And the limit at 2 plus, it was positive infinity. So now I have two remaining points over here, which is basically this point and this point. So how do we find these points? These points can be found using f of -1, because over here we are studying the function at -1. So we're going to replace -1 in the original function on top. And then we're going to do the same exact thing, but we're going to replace it with 5 as well. So first things first, f of -1 is going to be -1 to the power of 2 plus 5 -1 minus 2, which is going to be 6 over -3, which is going to be -2. So this is going to be -2. Now we're going to do the same exact thing with 5. F of 5 is going to be 5 to the power of 2 plus 5, 5 minus 2. 5 to the power of 2 is going to be 25 plus 5, it's going to be 29 over 5 minus 2, which is going to be 3. So it is going to be 29 over 3. And that's for the table of variation. Now, we also have an additional question for this function, which is basically over here, it is going to be about the concavity. So the concavity of these functions, what is concavity? Concavity is basically when you have a concavity is basically when you have an angle formed by the function itself. So for example, you notice over here that the angle formed is pointing downwards. So this is basically concave down. And the angle over here is facing upwards. So this one is concave up. So if the question is basically, state the intervals where it is concave down. So it is concave down from -infinity all the way till 2. Notice that I put 2 in curved brackets because 2, again, is not involved in the domain of definition. And concave up, it is going to be from 2 to positive infinity. Okay? So this is it for this question over here. And now we're going to start with the exponential function. Now, the first number, domain, as usual. The domain is always -infinity, positive infinity. There's literally nothing that can make this function undefined because exponential are easy to deal with. There's literally not a number that you can replace instead of x that would give you this function undefined. So the domain is going to be -infinity, positive infinity. Limits. The limit as x is going to -infinity for f of x, it is going to be e to the power of -2 -infinity, -1. So -2 times -infinity is going to be positive infinity, -1. e to the power of positive infinity is going to be positive infinity minus 1, which is positive infinity. Is there any asymptote over here? Since we're going at a vertical or a horizontal asymptote, there is not, because we have both infinities on two sides, so no VA and no HA in this case. We're going to do the same exact thing for positive infinity right now, which is going to be e to the power of negative 2 positive infinity minus 1, which is going to be e to the power of negative infinity negative 1. And in this case over here, e to the power of negative infinity is going to be 0 minus 1, which is negative 1. Now in this case, we are going to an infinity and we have a regular number. So in this case over here, I have y equals negative 1 is a horizontal asymptote. Okay, so this is it for the question about the limits. Now we need to find f prime of x and the table of variation. So the f prime of x, first of all, according to chain rule, first of all, let's write f of x again. So f of x is e to the power of negative 2x negative 1. So f prime of x, according to chain rule, which is basically u prime e to the power of u, so f prime of x is going to be negative 2 e to the power of negative 2x, and negative 1 is just going to disappear. So now we try to set it equal to 0. If f prime of x is equal to 0, then negative 2 e to the power of negative 2x should be equal to 0. So the only way for this to be equal to 0 is if e to the power of negative 2x is going to be equal to 0, because if you divide by negative 2 over here and negative 2, you're going to have that e to the power of negative 2x is supposed to be 0. But this is impossible, because e to the power of anything is always positive. It is never equal to 0 and it's never negative. Unless if you put a negative sign over here, of course. But since it's by itself, it is strictly positive, which is impossible over here. Because e to the power of u is always positive. This means that negative 2 e to the power of negative 2x is either always positive or always negative. Now, let's study the sign of f prime of x. So this is going to be my f prime of x, right? So negative 2 is always negative, and e to the power of negative 2x is always positive. But negative multiplied by positive is always going to be negative. So this function, this prime, this derivative is always negative. This means that there is no critical points, and this also means that the function is always going down, because f prime is always negative. So negative infinity, positive infinity, x, f. It is always going down. So we look at the limit. At negative infinity, it was positive infinity, which makes sense, because imagine this was negative infinity. So how can it be negative infinity and it's still moving downward? So it wouldn't make any sense. This is how we know that our answer is correct. So it is going from positive infinity all the way down to negative infinity, according to the limits. And this is it for number 3. Now, number 4, they would ask us, is the function monotone? And if so, is it strictly increasing or strictly decreasing? Since the function, since f of x is always going in one direction, then it is monotone. And since f prime of x is always negative, according to the sign that we have over here, so f of x, which is this one, is strictly, actually we like to say the word strictly, decreasing. That means it's always going down. This is it, guys, for today's video. Make sure to tune in on another day. I would be posting some videos about L'Hôpital's rule. And thank you so much.